Good afternoon, viewers and listeners. Welcome once again to Salida, TeleRadyo of the La Filipina National High School. I am your teacher host, Teacher Ramel and Abay. And today, you will learn many things about permutation. Lesson in Mathematics 10, Quarter 3. Are you all ready? Let's give the floor to our teacher broadcaster, Teacher KEIRSTINNE A. SONIDO.
Good afternoon, viewers and listeners. You are tuning in to Salida TeleRadyo of the La Filipina National High School, Cool Math on Air, in collaboration with 98.3 Gold FM, ang radyo astig ng Tagum City. Kuyawa no? I am Teacher KEIRSTINNE SONIDO, your teacher broadcaster on air. Before anything else, I would like to greet all the teachers of La Filipina National High School, headed by our ever-dynamic and ever-supportive School Principal 4, Sir Jeffrey C. Villarosa, and to all math teachers of La Filipina National High School, headed by our ever-active Master Teacher 1, Sir Edwin B. Amper. Good afternoon to all of you. This afternoon, we will be discussing an important topic in Mathematics 10, Quarter 3. Are you all ready? Yes, of course you are. So, have your pens and papers with you and brace yourselves as we get the ball rolling. This afternoon's lesson is all about permutations. Our objective for today's lesson is, at the end of the discussion, the students are expected to solve problems involving permutations. But before we proceed with the lesson proper, let's have first a short review of the topic, Fundamental Counting Principle. In every situation, there is at least one possible outcome. The fundamental counting principle is a rule used to count the total number of possible outcomes in a situation. It also states that if there are P ways to do one thing and Q ways to do another thing, then there are P times Q ways to do both things. For example, Carla has a friend who is about to celebrate her birthday. She is a bit confused of what gifts to give. She is thinking of a jewelry and a bag. If she bought 3 jewelries, a necklace, a bracelet, and a pair of earrings, and 2 bags, a shoulder bag, and a backpack, in how many ways can Carla choose as her gifts? What is the problem all about? Alright, naglibog si Carla kung unsa nga mga regalo ang iyahang ihatag sa iyang amiga nga mag-birthday. Pero, nakahunang-huna siya nga muhatag og isa ka alahas ug isa ka bag. So, what are the given? Very good. We have the 3 jewelries, the necklace, the bracelet, and the pair of earrings. And the 2 bags. We have the shoulder bag and the backpack. What is asked? You're right. Sa pila ka pamaagi, makapili si Carla sa iyahang regalo para sa iyahang amiga. In other words, pila ka paresang sa jewelry o bag ang pwede mahimo. Solution. First, we need to list down all the possible pairs of a jewelry and a bag. So we have a necklace and a shoulder bag, a bracelet and a shoulder bag, a pair of earrings and a shoulder bag, a necklace and a backpack, a bracelet and a backpack, and a pair of earrings and a backpack. Therefore, there are 6 possible ways. Or in other words, P times Q equals 3 jewelries times 2 bags equals 6 pairs of a jewelry and a bag. Are you ready now to proceed to our lesson proper? Good. Now, let us discuss permutation. When we say permutation, it is a mathematical technique that determines the number of possible arrangements in a set when the order or arrangement matters. In other words, permutation is an ordered combination, where order or arrangement of object is very important. So, pag moingon tawag permutation, ibig pasabot kung naatay isa ka set of numbers, for example, sa pila ka pa maagi nato ma-plus-star or ma-arrange ang mga numbers. To get the number of permutations for every situation, a formula is to be used. The permutation of n objects taken R at a time is permutation of n objects taken R at a time equals n factorial over quantity n minus r quantity factorial, where n is greater than or equal to r. In symbol, we have capital letter P, open parenthesis, small letter n, comma, small letter r, close parenthesis, equals n factorial over, open parenthesis, n minus r, close parenthesis, factorial. Wherein n refers to the total number of objects, r refers to the number of objects taken at a time, and n factorial is the product of all positive integers less than or equal to n, such as 4 factorial. So when we say 4 factorial, that is 4 times 3 times 2 times 1, which is equal to 24. And the permutation of n objects taken all at a time is, we have permutations of n taken n or taken all at a time is equal to n factorial. In symbol, we have capital letter P, open parenthesis, small letter n, comma, small letter n, close parenthesis, equals n factorial. For example, Mrs. May Ansacro, the watch coordinator of La Filipina National High School, organized a contest for the most punctual teachers, where the top 3 early birds will win a special prize. If there are 10 punctual teachers of the said school, how many possible ways can they be awarded as first, second, and third? What is the problem all about? Alright, it is about the contest of the most punctual teachers. What are the given? Very good. 10 punctual teachers and 3 awards. You have the first, the second, and the third. And what is asked? Exactly, the number of possible ways that the punctual teachers be awarded as first, second, and third. Solution. Since there are 10 punctual teachers, therefore our n is 10. And there are 3 awards to be given, the first, the second, and the third. So our r is 3. We're going to make use of the formula permutation of n objects taken r at a time equals n factorial over quantity n minus r quantity factorial. We just simply have to replace or substitute the values of n and r by 10 and 3 respectively. So we have permutation of 10 teachers taken 3 at a time is equal to 10 factorial over quantity 10 minus 3 quantity factorial. So we have the permutation of 10 teachers taken 3 at a time is equal to 10 factorial over 7 factorial. Permutation of 10 teachers taken 3 at a time equals 3,628,800 over 5,040. Therefore, The permutation of 10 teachers taken 3 at a time equals 720. But we can also have another way to solve this. So instead of writing 3,628,800 over 5,040, we can have it this way. We have permutation of 10 teachers taken 3 at a time equals 10 times 9 times 8 times 7 factorial over 7 factorial. Then, we have to cancel 7 factorial. What is left is permutation of 10 teachers taken 3 at a time equals 10 times 9 times 8, which is equal to 720. Therefore, the most punctual teachers can be awarded as first, second, and third in 720 ways. Another example. In how many possible ways can 7 desserts, mango float, macaroni salad, leche flan, spaghetti, brownies, cake, and cookies be arranged in a row of a buffet table? What is the problem all about? Alright, the arrangement of desserts in a row of a buffet table. What are the given? Very good, 7 desserts. And what is asked? Exactly, the number of possible ways that the 7 desserts be arranged in a row of a buffet table. In this case, since all desserts will be arranged in the buffet table, therefore, we are to make use of the second formula. So, our n equals 7, since there are 7 desserts. So, the second formula, permutation of n objects, taken n or taken all at a time equals n factorial. Just simply replace the value of n, which is 7. So, permutation of 7 objects or 7 desserts taken all at a time equals 7 factorial. And 7 factorial is equal to 5,040. Therefore, there are 5,040 ways to arrange the 7 desserts in a row of a buffet table. Now, it's your turn to practice. Ready your papers and pens as I will give you only a minute per item to solve the problems. Practice number 1. You secured your cell phone with a passcode. However, after a few moments, you suddenly forgot the passcode. You are only certain that the codes contain all the odd numbers from 1 to 10. How many possible passcodes are there if no digit is used more than once? Your 1 minute starts now. Up. Since the given are all odd numbers from 1 to 10, and odd numbers are numbers which are not divisible by 2, therefore, we have 1, 3, 5, 7, and 9, which means our n is 5. So, we are going to make use of the second formula. The permutation of n objects taken n at a time is equal to n factorial. So replace n by 5 we have the permutation of 5 numbers taken 5 at a time equals 5 factorial. And 5 factorial equals 120. Therefore, there are 120 possible passcodes. Practice 2. In how many ways can you place 9 different English books on a shelf if there is space enough only for 5 books? Your time starts now. Okay, time is up. For the given, our N is 9. Since there are 9 different English books and R is 5, since only 5 books are enough for the shelf. So, the permutation of N objects taken R at a time equals N factorial over quantity N minus R factorial. Replace the values of N and R by 9 and 5 respectively. So we have permutation of 9 English books taken 5 at a time equals 9 factorial over quantity 9 minus 5 factorial. So the permutation of 9 English books taken 5 at a time equals 9 factorial over 4 factorial. The permutation of 9 English books taken 5 at a time equals 362,880 over 24. Therefore, the permutation of 9 English books taken 5 at a time is equal to 15,120. So 15,120 ways to place 9 English books on a shelf. And that ends our lesson for this afternoon. Thank you so much, dear students, parents, and all the viewers and listeners for tuning in. Watch out for the next episode of Cool Math on Air. Once again, I am your teacher, broadcaster, Teacher KEIRSTINNE SONIDO, saying, mathematics is not about computation. It is all about understanding. Thank you and have a nice day.
That's great! Thank you, Teacher KEIRSTINNE. And thank you, viewers and listeners, for tuning in. I hope you have learned something about permutation. Once again, I am your teacher host, Teacher Abay, saying, if math is hard and so is life, then get over it. Have a good day. Bye-bye.